In 2023, something extraordinary happened. A technology that was supposed to take decades to develop arrived in months. Millions of people woke up to find that artificial intelligence could write essays, code software, and answer questions with startling accuracy. But here's what nobody's talking about. This technology is fundamentally broken in ways we don't fully understand. Welcome to the Intellectus, where we explore the science, the impact, and the ethical minefield of generative AI and large language models. Today, we're diving deep into why this technology is about to change everything and why you should care. Let's start with the basics. LLMs, large language models, are neural networks trained on billions of words from the internet. Think of them as incredibly sophisticated pattern-matching machines. They don't understand language the way you do. Instead, they've learned statistical relationships between words. Here's how it works when you type a prompt. The model breaks it into tokens, small pieces of text. Then, using something called a transformer architecture, it predicts the next token based on probability. It repeats this process hundreds of times, generating your response word by word. The large part is crucial. GPT-4 has 1.7 trillion parameters, adjustable weights that shape how the model processes information. That's roughly equivalent to the number of synapses in a human brain. But, and this is important, more parameters don't mean more understanding. They mean more capacity to find patterns. The real genius behind LLMs is something called the attention mechanism. Imagine you're reading a sentence. The bank executive was arrested after the robbery. Your brain instantly knows that bank refers to a financial institution, not a riverbank. How? The attention mechanism works similarly. It calculates relationships between every word in a sentence, assigning weights to show which words are most relevant to each other. This happens across multiple heads, parallel attention processes, allowing the model to capture different types of relationships simultaneously. Then there's the transformer stack. Information flows through dozens of layers, each one refining the representation. Early layers might capture grammar and syntax. Middle layers understand semantic meaning. Later layers handle abstract reasoning and context. The training process uses something called backpropagation and gradient descent. Essentially, the model makes predictions, compares them to actual text, calculates the error, and adjusts its weights to minimize that error. Repeat this billions of times, and you get an eerily intelligent machine. Here's where it gets disturbing. LLMs confidently generate false information. They hallucinate. A lawyer used ChatGPT to research case law and cited entirely fabricated court cases. A researcher asked Claude for sources on a study, and it invented citations with real-looking authors and journals. Why does this happen? Because LLMs are trained to predict the next token, not to verify truth. If the training data contains misinformation, the model learns to reproduce it. If a plausible-sounding lie fits the statistical patterns better than the truth, the model chooses the lie. There's also the problem of temperature, a parameter that controls randomness. At high temperatures, the model becomes creative but unreliable. At low temperatures, it's more conservative but repetitive. There's no sweet spot for perfect accuracy. And here's the kicker, the model has no way to know when it's wrong. It doesn't have access to real-time information. It can't fact-check itself. It's generating text based on patterns, not understanding. This is why an LLM will confidently tell you that the Earth is flat if you ask it to role-play as someone who believes that. So, what does this mean for you? Let's talk about jobs. A Goldman Sachs report estimated that AI could automate 300 million full-time jobs globally. But here's the nuance: AI won't replace all jobs. It will replace specific tasks within jobs. A radiologist won't be replaced by AI, but the routine screening part of their job might be. A lawyer won't disappear, but document review hours of tedious work will be automated. A programmer won't become obsolete, but writing boilerplate code will be trivial. The real disruption is happening in knowledge work. Writing, coding, analysis, customer service, these are all being transformed. Some jobs will vanish entirely, others will evolve. New jobs will emerge that we can't yet imagine. But there's an economic reality we're ignoring. If AI can do 80% of a job, companies won't hire two people. They'll hire one person and expect them to do the work of two. Productivity will skyrocket. Wages might not. Training data reflects human biases. If your training data contains sexist language, racist stereotypes, and discriminatory patterns, your model will learn them. And because LLMs are so good at pattern matching, they become incredibly efficient at reproducing these biases. A study found that GPT-3 was more likely to generate negative descriptions when given names associated with certain ethnicities. Another found that image-generating AI models produced fewer images of women in leadership roles, even when explicitly asked. The problem runs deeper than just offensive outputs. Biased AI systems are being used in hiring, lending, criminal justice, and health care. An AI trained on historical data will perpetuate historical discrimination. And because these systems are often opaque, nobody really knows exactly why they made a decision. It's nearly impossible to hold them accountable. There's no simple fix. You can't just remove bias from training data because bias is often implicit and subtle. You can add diverse data, but that doesn't guarantee fairness. You can fine-tune the model, but that's expensive and time-consuming. And every fix introduces new problems. Training a large language model consumes an enormous amount of energy. Training GPT-3 required approximately 1,287 megawatt-hours of electricity. That's equivalent to the annual electricity consumption of 130 American homes. And that's just training. Every time someone uses ChatGPT, it requires computation. Multiply that by millions of daily users, and you're looking at a significant environmental footprint. Some estimates suggest that AI could account for 10 to 15% of global electricity consumption by 2030. The carbon footprint extends beyond electricity. Data centers require cooling systems, which consume water. They require physical infrastructure, which requires mining and manufacturing. The environmental cost of AI is real and often invisible. But here's the paradox: AI could also help us solve climate change. Machine learning is being used to optimize renewable energy systems, predict weather patterns, and design more efficient materials. The technology that threatens our environment might also save it. The question is whether we can deploy it responsibly. Governments are scrambling to regulate AI. The European Union passed the AI Act. The US is considering various frameworks. But here's the problem: regulation is slow and technology moves fast. By the time a regulation is written, debated, and implemented, the technology has already evolved. We're trying to regulate systems we don't fully understand using laws written by people who might not understand them either. There are legitimate concerns. AI could be used for mass surveillance, deepfakes, autonomous weapons, and social manipulation. But overly restrictive regulation could stifle innovation and push development to countries with fewer safeguards. The ideal approach is probably somewhere in the middle. We need transparency requirements. Companies should disclose what data they trained on and how their systems work. We need accountability mechanisms. If an AI system causes harm, someone should be responsible. We need safety standards. Critical applications like healthcare and criminal justice need rigorous testing. But we also need to move fast. The technology is advancing exponentially. Waiting for perfect regulation means accepting the risks of unregulated AI. So, what should you do? First, understand that AI is not going away. It's not a hype cycle. It's a fundamental shift in how we process information and automate tasks. Second, develop skills that AI can't easily replicate. Critical thinking, creativity, emotional intelligence, and complex problem solving are still uniquely human. Learn to work with AI, not against it. The people who thrive will be those who can leverage AI as a tool, not those who compete with it. Third, advocate for responsible development. Support policies that prioritize safety, transparency, and fairness. Demand that companies disclose how their systems work. Push back against surveillance and manipulation. Fourth, stay informed. The AI landscape is changing weekly. Follow researchers, read papers, understand the technology. Knowledge is power, and in the age of AI, understanding how these systems work is essential. The future isn't predetermined. We still have agency. The choices we make today about regulation, about development priorities, about ethical standards will shape the world we live in tomorrow. Generative AI is the most important technology of our time. It's not just about chatbots or image generators. It's about the future of work, education, science, and society itself. The technology is powerful. It's also flawed, biased, and potentially dangerous. But it's also incredibly useful and full of potential. The question isn't whether AI is good or bad. The question is, how do we ensure it's developed and deployed responsibly? That responsibility falls on all of us. On researchers to prioritize safety, on companies to prioritize ethics over profit, on governments to create smart regulations, on educators to prepare people for a world transformed by AI, and on you as an informed citizen to demand better. The Intellectus is committed to exploring these questions deeply. We'll break down the science, examine the implications, and challenge the narratives. Because understanding AI isn't optional anymore, it's essential. If you found this valuable, please subscribe. Share it with someone who needs to understand this technology. And let us know in the comments what aspect of AI concerns or excites you most. Thank you for watching the Intellectus. See you in the next one.